Today we'll be talking about properties of exponential functions, or rules of exponential functions. So, when we're talking about properties of exponential functions, this is usually adding, subtracting, multiplying, or dividing these. And in order to do this, we have to make sure that they have the same base, or that they're a number. For example, if we wanted to do something like x squared times y cubed, that wouldn't work because they don't have the same base. So we'll be talking strictly about functions with the same base. So first we were going to talk about the product rule. This is when we are going to be multiplying exponential functions. So when we have a to the n times a to the m, then this will then become a, let's get that in black, a to the n plus m. Also, when we have a exponential function being multiplied to each other and they have the same power here, then when we're multiplying them, we can group the bases together. So it becomes a times b raised to the n. Now let's go over to an example of this. Say we have 2 cubed times 2 to the 4th. This is the same as 2 to the 3 plus 4, or 2 to the 7th. Also, when it is 3 squared times 4 squared, through properties of exponential functions, that is the same thing as 3 times 4 squared, or 12 squared, which equals 144. We use the quotient rule when we are dividing these exponential functions. So when we have a to the n divided by a to the m, this goes and becomes the same thing as a to the n minus m. And also, when we have two different bases in a fraction raised to the same power, we can do something similar to what we did last slide, where we group the a and the b, but keep the power, showing this is the same, and therefore simplifying the exponential functions. Now let's move on to some examples. When you have 2 to the 5th divided by 2 cubed, that is the same as 2, let's get that in black again, 2 raised to the 5 minus 3, or just 2 squared, which will simplify down to 4. Also, now we have 4 cubed divided by 2 cubed. If you can't do this with a calculator, you can use properties of exponential functions, and that becomes 4 over 2 cubed, as the power stays the same as the bases become divided, which is just 2 cubed, which then becomes 8.
When an exponential function with a power is raised to another power, the powers can be multiplied to simplify. So b to the n to the m would be the same thing as b to the n times m. Now, when a base is raised to 1 over a number, it's equivalent to the same number root as the base, which that sounds kind of confusing, but it looks something like this. We'll do an example on the next page to explain that better. So, when we have 2 times 3 times 2, or 2 to the 3 times 2, it's the same thing as 2 to the 3 times 2, which equals 2 to the 6th. Now, 8 to the 1/3 would look something like this, the cube root of 8, which is the same thing as 2. The negative exponent rule applies when a base is raised to a negative power. It is the same as 1 over the positive power, so b to the n. Let's do an example. So if we have 2 to the negative 3, is the same thing as 1 over 2 cubed. Here is a combination of some of the rules that we have previously explained to do a harder problem. So to start off this problem, what you would do is start with the parentheses. So x to the 5th to the 3rd is the same thing as x to the 15th. So now that we have x squared times x to the 15th, you can add those powers together. So you get x to the 17th over 8x to the 8th. Now using the quotient rule, we can do x to the 17th minus 8, which is the same thing as x to the 9th and then over 8. Keep in mind you can use the quotient rule because the base is the same. Now, the 8 stays at the bottom because it's the same thing as timesing x to the 9th. Oops, let me do that. It's the same thing as multiplying x to the 9th times 1/8.